Bismillahirrahmanirrahim. Assalamu alaikum. I hope everyone is fit. Let's start with the video. In this video, I'll be solving question number 3 of exercise 8.2 from the chapter number 8, projection of a side of a triangle. In this chapter, we are having three theorems. One is for obtuse angle triangle theorem, another is for acute angle triangle theorem, and then Apollonius theorem. Let's see which theorem is applicable for this question. In a parallelogram ABCD, prove this. So we are supposed to draw a parallelogram first. Let's draw the parallelogram. So if a parallelogram is given to us, this means its opposite sides are parallel and congruent. Let's label this parallelogram. It will be A, B, C, and D. We are supposed to take care of the order as well. So let's see what is we are supposed to write. We'll prove it as a theorem. So what is given to us? Given is ABCD is a parallelogram and opposite sides of parallelogram are equal and parallel. So side AB is parallel to side CD and side AD is parallel to side BC. Also, AB is congruent to DC and AD is congruent to BC, right? And then what you do, we are supposed to write what we have to prove. So that is given in the question. That is AC, square of AC plus BD is equal to 2 times of AB का square and BC का square, bracket close. That is you have to prove. Now we are supposed to do the construction. If you see from the two proof from the question that AC, so this means we are supposed to join AC and we are supposed to join BD as well. So what we will write and what we will construct, join A to C and B to D to form triangles. Triangle ABC is formed and triangle BCD is formed, right? So let's do the construction. The triangle will join A to C and we will join B to D, right? Now if you see the triangle ABC, right, if you see the triangle ABC, I'll just highlight it so that you can see it clearly. So triangle ABC, we are having B angle as the acute angle. So if we are supposed to apply the second theorem, that is the acute angle triangle theorem, we need to draw its projection. And same goes with the triangle BCD. If I highlight this BCD, so we can see that angle C is obtuse angle and we can also draw the projection of this CD. So let us draw the projection. So I'll be writing it first. Drop projection BE of AB on which side? On BC side, right? And again we are supposed to drop another projection for another triangle. Drop projection, it will be CF, let's say, of which side? Of CD, and on which side? On BC produced, right? So we are supposed to drop two projections. Let us drop these projections. So I'll be dropping it with black color. So this is going to be the projection of AB on BC, and this is going to be the projection of this one and this one. So these two are the projection. So let's label it. So AB, the projection of BE is a projection of the side AB, so it is going to be BE, and CF is a projection of the side CD. So these two are the projections, and this one is the complete figure. Now we'll further move with the proof and the statements. Okay. Proof, statements with reasons, and reasons we are going to write. Okay. So let's start with the first reason, first statement. In triangle ABC, so we are considering the red triangle. Angle B is acute, right? This is the reason will be from figure. We have drawn the triangle like this. So we are going to apply the theorem of acute angle triangle theorem, that is the second theorem. Theorem says the side opposite to acute angle. So if this is angle B, the acute angle, the side opposite to it will be AC. So the square of the side opposite to acute angle is equal to the sum of the square of the sides containing that acute angle. So acute angle is contained by this side and this side. So we are going to take this sum, and the square of these two sides will be AB whole square plus BC whole square, right? Diminished by twice the rectangle contained by this side. So rectangle is contained by this side, the side BC, and the projection of it. Okay, so we are going to write down the projection, which was BE, and we are going to write using acute angle triangle theorem, right? This is going to be our equation number 1. Now we are going to draw the we are going to apply the first theorem on this second triangle. In triangle, which triangle is going to be? It will be BCD, and if you see, angle C is obtuse, right? Angle C is obtuse. So what the theorem says, let's recall the theorem. The side opposite to obtuse angle. Now I am considering the yellow triangle. If this is the obtuse angle, the angle C, then BD is the side opposite to acute angle. So what we are going to write it over here, the square of the side opposite to obtuse angle, it is BD. That is equal to the sum of the square of the sides containing that obtuse angle. So if you see, the obtuse angle is contained by this side and this side, BC and CD. So we are going to take the sum and the square of these two sides, right? So we'll be writing down BC ka square plus that of CD ka square plus twice the rectangle contained by the side and its projection. So what side we are going to take now? The side BC, this one, this side BC, and the projection of it. Okay, so BC into CF we are going to write. So BC and CF. This is going to be equation number 2, and using which theorem? Using obtuse angled triangle theorem, right? Now if you see, we are going to add the two equations, so we'll be writing adding 1 and 2. So we are going to add the left hand side to left hand side and the right hand side to right hand side. So we'll be adding these two, so it will become AC whole square plus BD whole square, and we'll be adding all these terms on the right hand side. It will be AB square plus BC square minus 2BC and BE plus BC square plus CD square minus 2BC and CF. Now, and it will be, the reason will be from 1 and 2 we have added up, right? So now instead of these sides, we are going to write some other sides as in parallelogram opposite sides are equal. And if you see, we are going to have, we need to prove this thing, right? So if you see, let me highlight it, we are going to prove this. So we already got this left hand side. Now we, on the right hand side, we need A, B and B, C. So we convert all the remaining lengths into these two, A, B and B, C, right? So now we are going to change it. So if you see, A, B, instead of A, B, and you can say C, D, right? These two are opposite and equal. So instead of CD, we can write that AB, right? So we'll be writing down, this will be equal to AB plus, this is BC and this is also BC. So we can write it down 2 times of BC square, right? And here also, okay, one is with the plus sign because it was the obtuse angle triangle theorem. Okay, and instead of here also 2 times of BC and BF and CF, since these are the projections and we are having the same angles of the parallelograms, the projections will be equal. So here we can write in reasons that AB, for this side, AB is congruent to DC. Also, we have BE is congruent to CF, right? So instead of BE, we'll write down CF. And we have already added up these two sides, and instead of CD we are going to write the AB whole square and 2 times of BC and CF. So if you see, you can cancel these two terms and you just add up these two terms. So 2 times of AB square plus 2 times of BC square, right? So, and for proving it as it is according to the question, you can take 2 as common. Yes. So this implies that AC whole square plus BD whole square is equal to 2 times of AB whole square plus BC whole square. So it is proved. I hope you understand this sum. Thank you so very much. Allah Hafiz.